Hello everyone, this question is about differential equation. The variables x and theta satisfy the differential equation. Show that d theta, so the derivative of cotangent squared theta d theta equals this. Okay, so you may assume without proof that the derivative of cotangent is minus cosecant squared, of course using the MF19 formula. So the first step is to write down the cotangent squared in this form. So you put the square outside of everything, and then we look at the MF19 differentiation formula for polynomial differentiation. We just move the power, bring the power down, and the new power is n minus 1. So same thing here, we bring this power down. We have 2 times the new power is 1, but we have to use the chain rule, so we gotta multiply by the derivative of the base, which is the derivative of cotangent, which is minus cosecant squared. So this is what we get from the differentiation. Now cosecant is actually 1 over sine squared. So unfortunately this formula is not in MF19. We have to know the definition of cosecant. Cosecant is 1 over sine, so cosecant square is 1 over sine squared. So now for the cotangent, just combine and we get what we need to prove, 1 mark. Part B, solve the differential equation. So the differential equation is x sine squared, so we just rewrite this part down there. X sine squared theta dx d theta equals tangent squared theta minus 2 cotangent theta. So the first step is to separate the variables, so we make everything with x on one side, everything with theta on the other side. We do that by multiplying or dividing both sides by something. So here we multiply both sides by this guy, because we can now cancel out sine squared theta, and we can cancel out d theta, and on the right, well, there's nothing to cancel out on the right. So on the left we only have x dx, and on the right we just rewrite everything. Okay, so we divide tangent squared by sine squared, we get this, and we also divide 2 cotangent squared with sine squared, we get this. So the integral of x dx is the simplest integration, of course. The problem is the right hand side. So to integrate tangent squared over sine squared. So first of all, tangent is sine over cos. According to the MF19 formula, we have tangent is the same as sine over cos, which means tangent squared is sine squared over cos squared. Now if we multiply both sides by 1 over sine squared, we get tangent squared over sine squared equals, here we cancel out, so we have only 1 over cos squared, which is secant squared. Okay, so secant is 1 over cos, which means we can replace tangent squared over sine squared with secant squared, which is what we do here. Tangent squared over sine squared becomes secant squared. Okay, so in case you are wondering why do we have to use secant squared, well, because we have the MF19 integration formula for secant squared. The integral of secant squared is tangent squared. So now we can integrate secant squared, we get tangent. Okay, so not tangent squared, but just tangent. Okay, so the integral of secant squared is just tangent, and the integral of 2 cotangent sine squared theta, using the previous part, you see, if the derivative of cotangent squared is this guy, of course the integral of the right hand side is cotangent squared. So the integral of this guy here, including the minus, is cotangent squared. So we have integrated everything. Don't forget the constant of integration. just once on the right. And then it is given that x equals 2 and theta equals 1/4 pi. So we have the general solution. To find the particular solution, we need to find the value of c by plugging in the x and the theta. So if you just simplify, use a calculator, you get 2, use a calculator, you get 1, use a calculator, you get 1. In case you don't know how to use cotangent in the calculator, this is how. Because cotangent is actually 1 over tangent. So use your calculator, you get 1. So this means the c is 0, which means we have the particular solution. That's when the c equals 0, so there's no more c. This is the particular solution. Now find the x when theta equals 1/6 pi. So we replace the theta with 1/6 pi, 1/6 pi. And we use a calculator. So here you use a calculator, you get root 3 over 3, and you use a calculator, you get 3. Again, in the calculator, for cotangent, we use 1 over tangent. So this is what we get from cotangent squared 1/6 pi. And question is to find x, so multiply both sides by 2, and then we take the square root of both sides. We get 2.67 in 3SF. Okay, in case you are wondering why do we use the positive square root, why not the negative, why not both? Well, because in the question the x is positive. Alright, I'll see you again next time.